Now we're sketching the curve f of x equal x squared over x squared minus 1. So, like in the other examples, we're going to start with the information from f of x. Okay, so here we get x-intercepts from the numerator, so the x-intercept, one x-intercept at x equals 0. And we get asymptotes from the zeros of the denominator. So we see that we have vertical asymptotes at x equal 1 and x equal minus 1. All right, what else? Let's see. We need the y-intercept. Well, the y-intercept is also 0, 0. The x-intercept is 0, 0, and so is the y-intercept. And finally, just end behavior. So as x goes to infinity, x squared over x equals 1 is the end behavior. So we have a horizontal asymptote at y equal 1. As x goes to minus infinity, same situation. So that's horizontal asymptote at y equal 1. So that's f of x information. Let's go to f prime of x, where we get increasing, decreasing, max, min. All right, so first let's take the derivative. Okay, so f prime, let's see, square that denominator. Put the denominator here. Derivative of the numerator minus derivative of the denominator times the numerator. All right, let's simplify. And we have 2x cubed minus 2x cubed, so the whole thing simplifies, the whole numerator simplifies to minus 2x. So we see that when the numerator is 0, that'll be a critical value. So x equals 0 is a critical value. The zeros of the denominator are not critical values because they're vertical asymptotes. So, but we're still going to put those on the number line. We always put zeros of the numerator and denominator on the number line for the plus minus analysis. So x equal 1, x equal minus 1, those are going to go on the number line. All right, so let's do the analysis. Putting 0 and putting 1 and minus 1. Those are the vertical asymptotes. All right, looking at f prime, if we substitute in something bigger than 1, let's say 2, look, the denominator is always positive because the whole thing is squared. So if we substitute in 2, we get negative. Let's say, let's say we substitute in 1/2, still negative. We substitute in minus 1/2, then the numerator is going to be positive, so that'll be positive here. And let's say we substitute in minus 2, again, numerator is positive, denominator is positive, so positive. So here we have increasing, increasing, okay, and decreasing, decreasing. And here we have a max. So we have a max at 0, 0. All right, that's our f prime of x information. Let's go on to f double prime. Okay, we're taking the derivative of this, f double prime. Square that denominator, so we have x squared minus 1 to the 4th put the denominator here, x squared minus 1 squared. Derivative of the numerator, that's minus 2, minus derivative of the denominator, there's a chain rule there, 2 x squared minus 1 to the 1 times 2x times the numerator times minus 2x. At this point, we're going to cancel out an x minus 1 squared from the denominator and the numerator. So let's do that. So, sorry, just x squared minus 1. X squared minus 1 from denominator and across the numerator. So if we cancel an x squared minus 1 from the denominator, this goes down to 3. This goes to 1 when we divide, and this one cancels. All right, so now let's rewrite f prime, simplifying that numerator. So in the denominator now we have x squared minus 1 cubed. And the numerator simplifies to, just multiplying everything out, simplifies to 6x squared plus 2. All right, so we want to put zeros of the numerator and denominator on the number line. Well, the numerator is never 0. Whenever you have something, this is all 6x squared is positive plus 2, so that will never be 0. In fact, that's always greater than 0. Okay. All right, and the denominator is 0 when x is equal to 1 and minus 1. So we're just going to put 1 and minus 1 on the number line. Evaluating f double prime. Minus 1 and 1 get open circles because they're vertical asymptotes. And this is always positive. The numerator is always positive. The denominator, here we have an exponent of 3, so sometimes it's positive, sometimes it's negative. All right, let's substitute in 2. Numerator is always positive. Denominator, when we substitute in 2, we have 4 minus 1 cubed, that's positive. If we substitute in 0, we have minus 1 cubed, that's negative. And let's say we substitute in minus 2, so we have 4 minus 1 cubed, that's positive. That means on this interval, from minus infinity to minus 1, the curve is concave up, in the middle concave down, and on the right of 1 concave up. All right, let's put everything together and draw a curve. Okay, so starting with f of x, we're going to put in that x-intercept, that's 0, 0. We're going to put in the vertical asymptotes at 1 and minus 1. Just draw some dotted lines here. We have end behavior. We have the curve leveling out at 1. So that means the curve is going to flatten out at this point, either above or below. We're not sure which one yet. Okay, so that's all the information we get from f of x. So we're going to move down to f prime of x. Okay, here's f prime of x. We have a maximum at 0. So let's put in the maximum over there. And let's see. These are asymptotes, and this is a maximum. And we have the curve is increasing from minus 1 to 0. So that means that the curve is going to go down on this side of minus 1. And from 0 to 1, the curve is decreasing, so the curve is going to go down here. You see, on this side, from minus 1 to 0, it's increasing. So let's see if we follow it along left to right, it'll be increasing here. And again, left to right, it's decreasing between 0 and 1. So that it looks like that's the way the curve should go. What about to the right of 1? Well, to the right of 1, the curve is decreasing. So at the asymptote, it's going to be either up here or down here? Well, if the curve is down here, then it's going to increase to get to that horizontal asymptote. And that's not the case. The curve is decreasing, so it must start up here at the vertical asymptote and decrease down to that horizontal asymptote. Okay, and over on the other side to the left of -1, the curve is increasing. All right, so it can't be going down here at the vertical asymptote. See, at the vertical asymptote, either it's going down or it's shooting up. But if the curve is increasing, it must be shooting up at that vertical asymptote of -1. Now let's just confirm that by what we have, the information that we got about the concavity from f double prime. Well, here's f double prime, and we see that from 1 to infinity, the curve is concave up, and that's the way we drew it. Between -1 and 0, it's concave down, and between -infinity and -1, it's concave up. So that's the way that confirms what we drew before. We also have no inflection points. Notice these are not inflection points because they're asymptotes. So we have no inflection points here. And we don't see any inflection points in this graph. All right, so that looks right. So that's the graph of y equal x squared over x squared minus 1.